Let's talk about 3D primitives and why you should know about them when making 3D games in libGDX. So libGDX provides a set of built-in 3D primitives, or 3D shapes, which are programmatically generated models using mathematical functions and subroutine to create the model vertices on the fly. The most common shapes are the box, sphere, cylinder, cone. Additionally, libGDX also provides the arrow, capsule, and the LineGrid. There are many benefits of using 3D primitives compared to loading external models created by a 3D software. First off, for basic 3D models with well-defined geometries, using the built-in shapes gives you more flexibility because you can customize the parameters right in the code while initializing models. Secondly, when making 3D games, 3D primitives can be used as temporary entities before loading the actual 3D models. Also, you can use 3D primitives as the basic building blocks for a more complex model. And finally, the box shape can be used to visualize a 3D axis-aligned bounding box for collision detection. In the real-world scenarios, there are actually several games and applications which are built with only 3D primitives. For example, Minecraft literally contains thousands of 3D tiny primitives called voxels. The 3D room I create in libGDX using only the box primitives to construct the wall in the pictures. The 3D carousel uses 3D boxes to construct the carousel items. You can check the video in my channel to know how to develop it. In my 3D first-person shooter game Quark, I built the world map using only 3D boxes to procedurally generate the walls and rooms. My 3D puzzle game uses a bunch of 3D boxes with box 3D physics to build the game board and the game items. In libGDX, 3D primitives are called 3D shapes and they have some common parameters such as the width, height, and depth parameters. And just like any models, they can have solid column materials or texture image applied to them. To play with these shapes, check out the link in the video descriptions where you can run a demo application which showcases 6 different types of 3D primitives in libGDX. Now let's go through each shape types and see how we can create them. The box shapes is the most useful and it has many applications which I showed you before. Using Model Builder, you can call the createBox method to generate a box with the parameters such as width, height, and depth. A 3D spheres with custom width, height, and depth parameters. You can also modify the division use and division V parameters, which increase or decrease the surface smoothness. A 3D cone, you can change the base dimensions by adjusting the width and depth parameters, while the height parameters specify the cone height. The divisions parameters also controls the surface smoothness. The cylinder is similar to the cone, but it has 2 bases at the top and the bottom. The capsule is a specialized shape of the cylinders. You can adjust the radius, the height, and the division parameters. A LineGrid is a 3D plane with its surface divided into rows and columns of cells. You can control the grid size and the number of divisions in horizontal or vertical axes. The arrow shapes points from one vector tree location to another vector tree locations. This can be very useful and handy for debugging entity directions. Especially if you combine the arrow and the LineGrid, you can build a simple visualization for a 3D coordinate system like this easily. This is especially useful for debugging 3D entities, positions, and directions. To get started with 3D shapes, use the 3D starter templates. Just copy and display the code in your entry class, then import on the missing dependencies and you're good to go. And that's all for today. I hope you enjoyed these videos. See you next time.